Let us start today's class. It is about quantum mechanics. We are giving an we are going to check the introduction of quantum mechanics. First, we will study the two slit interference experiment, that is Young's double slit experiment. Here you have already studied it in your plus 2 classes itself, that you if you have a laser source which is shining on two slits which are very close to each other, then you can see here the experiment setup. When the laser source is shined on the two slits which is placed on a screen, they are close by, very close by, and the slit size is very small. And if you are detecting the light beam on a screen which is 1 meter away from the slits, so we are detecting the light intensity on that screen. The detector is placed there. So if you detect, you will see the pattern. It will not be a bright too bright area. It will not be like that. It will be fringes like pattern. That means large intensity, low intensity, and large intensity, low intensity pattern will be seen, as you can see the green picture there. Okay, so we have the experiment now, and now we have to explain how we got these fringes. This experiment you might have studied in your plus 2 classes itself, but how will you explain it with quantum mechanical nature of the light, quantum nature of light? That is what we are going to study now. This is the experiment says that the two slits are two coherent independent sources with light beam with the same phase and intensity is coming out of the slit, and they interfere each other to get the interference pattern on the screen or on the detector which is placed on the screen. This is what the experiment says. The things which is written here in this next slide is not so important, but you just need to know that this is not really explained by the wave theory, or it should be explained with the quantum nature of light also. So that is what we are going to check, how we can explain the double slit pattern, the interference pattern on the screen using quantum mechanics. So we are going to explain it with the quantum mechanical nature of the light. So the pattern on screen are result of distribution of photons. Also we know that the light beam is incidenting on the detector like a pattern, as we see the intensity pattern there. So it will be distribution of photons. Large distribution means more distribution means more intensity there. So we see the pattern which is the distribution of photons there, and no way of anticipating where particular photon will strike. So we cannot explain or we cannot predict a particular photon will strike on a particular place. We cannot predict that. The predictability we cannot accurately say. So that is one of the point in quantum mechanical interpretation. And also it is impossible to tell which path photon took. So that is what the same which I have said in the second point itself. We cannot anticipate on which position the photon will strike and which path it will take. Both are together, you can say, both together we can say. So the trajectory of photon is not predictable. And third one is, cannot suppose that half went through one slit and half through other. So half of the light passed through the first slit and half of the light passed through the second slit. We cannot say that. We cannot predict the path of the photon. We can just only say, what do we say then? We can only say the probability of light beam passing through one slit and the other slit. Okay, so this is what we study here in quantum mechanical interpretation. So we can only predict how photons will be distributed on screen. So this is the prediction. So probability only we can say. So interference and diffraction are statistical phenomena associated with the probability. So here the probability comes into play. That is, the diffraction and interference are all there in the classical explanation, but when you go to quantum mechanical explanation, these interference and diffraction, we can only say their probability. Diffraction can happen in this much probability, and interference can happen in this much probability. So it is a statistical phenomena. That's what they say in quantum mechanical interpretation of Young's double slit experiment. So high probability means bright fringes. So maximum probability of hitting an electron in one point means there will be a bright fringe. So maximum probability is there, so we expect a bright fringe there. Okay, low probability means dark fringes. Okay, so this is how we explain the double slit experiment with the quantum mechanical interpretation. But we know already using this interference and diffraction phenomena, wave nature of the part, because of the wave nature of the light beam, it diffracts and it interfere each other. The beams interfere each other. Because of that only we see the pattern on the screen. These things we have already studied, but these are all a classical explanation. If you come to quantum mechanical explanation, instead of saying the wave nature, we are saying that along with this wave nature, it has particle nature also. The light beam has both particle and wave nature. So the probability of the striking of one photon at a point, we are predicting it or we are calculating it, and that probability, if it is high, that means the fringe will be having maximum intensity, bright intensity. It will be the bright area. The fringe will have bright area at that point. So that is how we explain the experiment. We have see here in this slide, there is a connection between wave theory and quantum theory. Using both of these theory, we can explain the double slit experiment. So first one, wave theory says pattern of fringes, it is intensity bands due to variation in square of amplitude of resultant wave on each point on a screen. So intensity band happens by the diffraction of the light beam or the interference of the light beam. Diffraction comes at the diffraction happens at the slit points, and each slit will produce light beam as a single source or a coherent source, and these two beams interfere to get the pattern there. So the intensity at a point will be calculated as its amplitude square, the variation in square of amplitude, which results in the intensity. And a role of the slits, what is the role of slits in wave theory? It provides two coherent sources of secondary waves. So at the point of two slits, at the start, at that point two light beams of coherent light beams are emitted at same time, and they interfere each other. So the two coherent sources are the secondary wave source that can interfere on the screen. But in quantum theory, how the pattern of fringes is explained, it is due to the variation probability of photon striking that point on the screen. So a fringe having bright area means probability is maximum. A pattern which has less bright dark area means it is having low probability of striking the photon on that point. Okay, so that is how pattern of fringes explained in quantum mechanics. And role of the slits, what is the role of slits? It represents or it presents two potential route by which a photon can pass from source to screen. It is just the route to pass the photon through it. So it is just the source to screen. It is just a source of photon which comes the source of photon, that's all. Now we have already said that the bright fringe and dark fringe, we explain it with the probability of photon striking on the screen, and we here say that the quantity with which the quantum mechanics is concerned is the wave function of a body. So what is a wave function now? Wave function means if you have a particular system, for example, if you have a light beam coming out of a slit, so that light beam we represent it with a wave function. So wave function means it's just a mathematical function or mathematical term which is going to represent full properties of that wave which is coming out of the light coming out of the slit. So if you have a light beam coming out of a slit, if you want to explain its complete property of that means the wave's complete property, you need to express you need an expression, you need a mathematical expression through which you can explain the complete property of that wave. So that complete mathematical expression, we call it as wave function. So if you have a wave function, if you are given a wave function, with that wave function you can completely understand its property, its position, its speed, its energy, its intensity, all the things you can understand, whatever be the system. Now we just considered a light beam. It can be a particle in a box, or it can be a body which is moving with a speed, or which is at a rest. So anything in this world you can explain it with a wave function. So wave function means it's just a mathematical expression by which you can explain all the properties of a system. So we call it as a system. Okay, so it is the quantity with wave function is the quantity with which a quantum mechanics is concerned, and it is representing full properties of a body. So wave function psi is a quantity associated with the moving particle. It is a complex quantity. It can be complex, it can be real also. It will be normally complex quantity. So when you have a term, we are representing with a symbol psi for telling the wave function. So psi represents wave function. So if you take the modulus of psi and take the square of it, so I have already said that psi is now complex quantity, and if you take the modulus of it, modulus means we know that. So modulus square means it is the probability density. That is, it is proportional to the probability of finding a particle at a particular point at a particular time. So if psi represents the wave function of a particle, so here the system is a particle. So if psi represents the wave function of a particle, psi modulus square represents its probability of finding that particle at a particular time. So now you are taking probability density psi modulus square means psi star psi. What is psi star? If psi is a plus ib, psi star will be a minus ib. So that's all. So complex conjugate. So psi is a plus ib, then psi star will be a minus ib. So if we take like that, psi star psi will be a square minus I square b square. That means a square plus b square. So it is the real quantity which will be a number. This psi modulo square always should be a number. What is that number? It varies from 0 to 1. So if it is 1, that means 100% probability. If it is 0.5, that means 50% probability is there to find that particle in a particular time. So that is what psi says, or psi modulus square says. Psi modulus square means the probability of probability density. We call it as probability density. If psi represents the wave function of a particle, then psi modulus square is the probability density of finding that particle at a particular time. Now, what is called normalization? So we know now wave function. Wave function means it's a mathematical function to represent a system. Here, if a particle is considered as a system, the particle's full property will be represented in the wave function psi. So psi can be complex quantity, and psi modulus square will be its probability density. Okay. So now what is normalization? Normalization is, we know that psi modulus square is the probability density, and normalization means we know that this particle will be somewhere in this world, in this universe. It should be somewhere in this universe. If a particle is considered, it should be somewhere in this universe. So if you take the integration of this psi modulus square, the probability density, if you take the integration of it over the whole range, minus infinity to plus infinity, over the whole universe, so minus infinity to plus infinity, then the probability will be 1, isn't it? So somewhere it is there. So 100% sure it is there somewhere from minus infinity to plus infinity. So if you take the integration over minus infinity to plus infinity of the probability density, then it should be always 1. So that means if psi modulus square d over all over the whole universe, if you take the integration, if it is 1, that means that wave function is normalized, psi is normalized. So that means that particle is there somewhere. If that particle is not here in this world, in this universe, then it should not be 1, it will be 0. So if psi modulus square, if you take the integration minus infinity to plus infinity, if it is 0, that means it is not normalized. If it is not 1, if it is half, it is also not normalized. That means it is only half chance is there, so it's not there. So that is what we say. Psi normalized means you should know that, you should say that it's integration over minus infinity to plus infinity, psi modulus square d tau should be equal to 1. So this is called a normalization. Now if you are given a wave function psi, which is, let it be e raised to x. So psi is equal to e raised to x, exponential x. It's a mathematical expression which is going to describe a particle, for example a particle. So if you are given psi is equal to e raised to x, then if you take the integration of psi modulus square, e raised to x is not complex, so e raised to 2x, psi modulus square will be e raised to 2x, and e raised to 2x, if you take the integration minus infinity to plus infinity, if it is equal to 1, that means that wave function is normalized. So e raised to 2x, if you are integrating, you don't get what will you get, you just check. So if it is equal to 1, that means that wave function is normalized. If it is not equal to 1, then it is not normalized. So if it is having a value, a number n, so that n will be the if you do the integration minus infinity to plus infinity psi modulus square d tau, if you get n square there, let it be n square instead of 1. If it is n square, then that n will be the normalization constant. You will learn that later. N will be the normalization constant. Now, what are the properties of a wave function? So let us see how we can explain a wave function with its properties. So first property is, it must be finite everywhere. That means it should not be infinite. If psi is infinite for a particular point, it means what? It means it means an infinite large probability of finding the particle at that point. So that means if psi is infinity at a particular point, that means if you take the integration over minus infinity to plus infinity, psi modulus square d2 will be infinity. So that means it has infinity probability. So that is not possible. So this would violate the uncertainty principle. So uncertainty principle say that what is uncertainty principle? You cannot determine completely and simultaneously or two properties together, isn't it? So that is this will violate the uncertainty principle. The probability will become infinity. That means it's not correct with the uncertainty principle. So it must be finite everywhere, and if it must be single valued also. So psi must have a single value. It should not have at a point it should not have 2 or 3 values. It should have only one value. So psi has more than one value at a point. It means more than one value of probability of finding the particle at that point, which is obviously ridiculous. It's not correct. So it can have only one probability at one time, at one point. It must be continuous and have a continuous first derivative everywhere. So you should remember these 4 points. It will be asked surely in your exam. These 4 properties of wave function will be asked, so you should remember it. What is its third property? Dou psi by dou x and dou psi by dou y and dou psi by dou z must be continuous. So if you take the derivative of it, the wave function should be continuous. And also continuous means its derivative should be positive, and it must be normalizable. So normalization, what is normalization? I have said in the previous slide. You can see normalization means if you are given a wave function, you just take its modulus square, psi modulus square d2, then integrate it with minus infinity to plus infinity. What do you get out of this integration? If you put it as n square, then that n will be square root of n square, that is n will be the normalization constant. So if you divide this wave function psi with that n, the normalization constant, then you will get a resultant other wave function. Psi by n is equal to psi star. So psi star, this new wave function will be normalized. So this is called a normalization. So always psi should be normalizable. നോർമലൈസ് ചെയ്യാൻ പറ്റാത്തത് ഒരിക്കലും അതിനെ ഒരു വേവ് ഫംഗ്ഷനായിട്ട് കൺസിഡർ ചെയ്യാൻ പറ്റില്ല. സോ വേവ് ഫംഗ്ഷൻ ഷുഡ് ബി നോർമലൈസബിൾ. ദ വേവ് ഫംഗ്ഷൻ ഷുഡ് ബി continuous and its derivative also should be continuous. Psi should be continuous and its derivative also should be continuous. And what is the next one? It should be single valued and it should be finite. So these are the 4 properties of a wave function. Now let us go to Schrodinger time independent wave equation. So let us take psi as a into, so here a one dimensional wave equation for the waves associated with a moving particle. So here wave function is represented with a into e raised to minus I by h cut et minus px. So this is the wave function of a moving particle in one dimension. Okay. So we write it with a wave equation. So wave equation is a into e raised to minus I by h cut et minus px. So this is a mathematical expression which is called psi there in the psi for that system. That system means a moving particle in one dimension. Okay, so here one dimensional wave equation. So this particle is considered as a wave. So here we represent it with a wave equation. So this is the wave function psi. Now if psi, you can see here, if we take psi at x and t is equal to 0. So if t is 0, that means the expression becomes a into e raised to minus I by h cut, minus will become plus, so minus I into minus px. So et will be 0, t will be 0. So a into e raised to I by h cut px will be the wave function psi. So px we have represented with the wavelength lambda. So p, we know that it is mv. So when you substitute for that, you will get the equation a into e raised to 2 pi by lambda into I into x. Okay, so now we have here the new wave function psi, which is not depending on time. Okay, so you have to take that second wave function psi, which is a into e raised to 2 pi I by lambda into x. So now lambda is the wavelength, a is the amplitude, and we take the first derivative, and then we first derivative of this wave function psi with respect to x. Dou psi by dou x you take, and then you take once more with respect to x, you take one more derivative. So once more you take the derivative. So dou square psi by dou x square you will get, and that will be equal to minus 4 pi square by lambda square into psi. If you take first derivative, it will be dou psi by dou x, which is equal to what is a into e raised to 2 pi by lambda ix into 2 pi I by lambda. So if you do it 2 times, 2 pi I by lambda will come 2 times. So it will be minus 4 pi square by lambda square psi. So you don't take the value a there. A is just a constant, so we don't take it there. Now if you do the de Broglie's wave equation, which is lambda is equal to h by p, which is h by m0v, then 1 by lambda square will be m0v square by h square. And then if you substitute that, you will get if you do this small change, multiply with the 2m0 and then half m0 v square, that will be m0 square v square itself. That means 2m m0 into k by h square, where k is the kinetic energy. Now you will get 1 by lambda square is equal to, what is 1 by lambda square? 2m0 by h square into k, isn't it? So if E is the total energy of the particle and V is the total energy of the particle, then kinetic energy will be total energy minus potential energy. So 1 by lambda square becomes 2m0 by h square into E minus V. Now let us substitute in equation 2. What is equation 2? Dou square psi by dou x square is equal to minus 4 pi square by lambda square. So 1 by lambda square we substitute as 2m0 by h square into E minus V. So that equation becomes, right hand side is equal to minus 4 pi square by h square into 2m0 into E minus V into psi. So this is now moved to left, and it is now a new equation which is called time independent Schrodinger wave equation. So this time independent Schrodinger wave equation is the equation which is just above the just this dou square psi by dou x square plus 2m0 by h square into E minus V into psi is equal to 0. If you have this is in one dimension. If you have 3 dimension, you can write, instead of dou square psi by dou x square, you can write as dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square, which we can tell it as del square. Normally we in MSc classes we say del square. See, it is there written there in the below equation. See, dou square by dou x square plus dou square by dou y square plus dou square by dou z square is del square. So del square of psi is equal plus 2m0 by h square into E minus V into psi is equal to 0. And this is called 3-dimensional time independent Schrodinger wave equation. If V is 0, you can reduce it as del square psi plus 2m0 by h square into E psi is equal to 0. Okay, this is the Schrodinger wave equation, which is time independent. And time independent wave equation, how did we get? We just took the wave function psi as a term which is not depending on time. See here, it is not depending on time. Psi is equal to a into e raised to 2 pi by lambda into ix. That is the equation which we took, which is not depending on time. That is why we got the time independent Schrodinger equation. If you take the first equation, which is depending on time, if you take that, then you will get time dependent Schrodinger equation. Okay, that I will teach you next class.